So today we're going to continue on with our prerequisite chapter. We're going to continue on again with section 4. This is day 2 of factoring. So today what we're going to focus on is factoring perfect cubes and factoring 4-term polynomials by grouping. So the first thing we're going to do is learn how to factor a perfect cube. So it'll be beneficial if you can recognize when your first and your last terms are perfect cubes. Now, unlike the difference of two squares, we can actually have both a sum and a difference of two cubes. And you're going to memorize the pattern. So when you have the sum of two cubes, the u cubed plus v cubed is going to be u plus v. So u plus v times u squared, opposite sign of the original, and then u times v, always positive, and then the v squared. This will be the pattern that you need to memorize. When it's the difference of two cubes, we'll start out again by putting u and the v, but this time same sign, so it was already originally subtraction. And then I square the u, opposite of the original, and then u times v, always positive, the v squared. So notice it has the same u's and v's. What's changing are the signs in between each term. And I've got an acronym to help you remember what signs go into each one. My acronym is the word SOAP. Same sign, opposite sign of the original, and then always positive. So this first S here is referring to the same sign of the original problem. So notice this first one had an addition sign. This one had a subtraction sign. So when the sign is the same, so the first binomial gets the same sign as the original. Then the second sign that you're going to write is going to be the opposite of the original. So this sign that's here is opposite of the original sign. So this will be, oh my goodness, what happened there? Let me fix that. Same sign of the original. And this one is going to be opposite of the original. And then the last sign in that trinomial, this AP, is going to be always positive. That's the AP. So always positive. So think SOAP. So let's figure out how we can get these U's and these V's. So the way that we're going to find the u is we're going to take our perfect cube, our u to the third, and we have to cube root it, and that'll give us the u. Because when you cube a cube root, it just cancels it. And then the same thing for the v. The v will be a perfect cube. You'll cube root it, and it gives you the v. So let's go ahead and try it. Try a first example. You're going to need to be able to recognize perfect cubes, just like I told you to recognize perfect squares. So for the first example, I'm going to come and write it below here so I have more room. So it's x to the third minus 125. So in order to get my u value, my first term is u to the third. So to get u, what I'm going to do here is I'm going to cube root it, and my u value is just x. Then I'm going to do the same thing for the 125. I'm going to cube root it, and that will give me my v value. And now I'm going to take my pattern. So the original problem was the difference of two cubes. So the pattern I'm using is going to be u minus v, same sign as the original problem, square the u, opposite sign, multiply the u and the v, and then the last one always positive, square your v term. So let's fill it in. So my u value was x, my v value was 5. I'm now going to square the x, that's my u, so x squared, and then now u times v is going to give me 5x, and then always positive, the 5 squared becomes 25. So this is 5 squared. Now, the trinomial that we end up getting can never be factored any further. So whenever you factor a cube, don't think that that's a perfect square trinomial. You can't factor that any further. So we're done. The perfect cubes are going to get rather large quickly. So make sure that, if you're not recognizing something, you're just going to multiply a number 3 times and then recognize to see if it ends up being a perfect square or a perfect cube. Let's try some more examples. You should always be looking for a greatest common factor first. However, the first 3 examples here do not have a GCF that you can divide out. But when we get to number 4, that one does have a GCF. But let's go ahead and take them one at a time. So for number 1, again, to find your u value, you're going to take x to the third and we cube root it, which would give me my u value to be x. Then I'm going to do the same thing for the v. I'm going to cube root the 27, and my v value is 3. We're not looking at the sign because the sign just tells us which SOAP pattern we use. So now that I've got my u and v, I can put it into the pattern. So remember, the pattern is u, in this case, my same sign is subtract. So I'm going to do x minus 3. Then my trinomial, remember you're going to square the u, and my u value is x, so x squared. Opposite sign of the original, multiply the 3 and the x, gives me 3x, always positive, and then now square the 3. And you're done. Now, once you get the hang of this, you don't need to show me what the u and the v value are. Just know that you're cube rooting both terms, and that's what's going to give you your u and your v value. So again, I'm cube rooting the y to the third, which cancels it. So my u value is y, and then I'll do the same thing to the 8. I'm going to cube root it, and that gives me a v value of 2. So then now I'll put it into the pattern, and I'm going to use the same sign. So it's going to be y plus 2, and then in the next binomial or trinomial, I'm going to square the y. I'm going to multiply the u and the v, but it's opposite sign, so I get 2y now. And then the last term, always positive, square that v, and I get a 4. And again, the trinomial, you cannot factor any further. At first glance, you might think it's a perfect square trinomial, but it's not. Let's try number 3. still two perfect cubes, the difference of two perfect cubes. Now you may look at it and say 64 and 1 are perfect squares, but notice the exponent on the x, it's a to the third power. So these are perfect cubes as well. So I'm going to cube root the 64 x to the third. Once I cube root that, my u value is 4x. And then I'll cube root, actually I'll cube root the 1. And 1 times 1 times 1 is 1. So the cube root of 1 is 1. So my v value is 1. And now I'll put it into the pattern. Now watch this one, be careful. So in the first binomial, you just put your u and your v. So 4x, same sign, subtract with the v. Now remember, in the trinomial, what we're putting here is u squared. And remember, your u was 4x. So I need to square the 4 and the x. So what's going in here is 16x squared. And then the next term is going to be the u times v. So what we're doing here is 4x times 1. So then opposite sign, and this is just 4x. And then finally last, always positive, 1 squared is 1. And you're done. So be careful when that first term, after you cube root it, if it's got a coefficient, don't forget to also square the coefficient. Now the next one, if you recognize, 3 and 192 are not perfect cubes, but I can factor out a GCF of 3. So I'm going to divide both of the terms by 3, and now I'm left with x cubed plus 64. I still have perfect cubes, the sum of two perfect cubes, so now I do my pattern. So again, I would find my u value by cube rooting the x to the third, so u is x, and then 64, find the cube root, and my v value is 4. And now let's put it in the pattern. So it'll be x, same sign, so plus 4. And don't forget your GCF. If you forget to bring the 3 in the front, I'm taking off points on the quiz next week. You must include the GCF that you divide by in the original. So now I got to square the x, multiply the 4 and the x, opposite sign, and then square the 4. And you're done. Same thing. Two perfect cubes, the sum. So I'm going to cube root the 27, x to the third. And again, once you start to get the hang of this, you don't have to show what you're doing. The cube root of 27 is 3, and the cube root of x to the third is x. And then the cube root of 1 is 1. So it's got the same sign. Now remember, in this first term, you're taking that 3x and squaring it, so 9x squared. Opposite sign, multiply the 3x and the 1, and then last, square that 1, and you're done. So this is 1 squared, and then this one was the 3x times 1, and that's how I got that. Next one, two perfect cubes again, difference. So again, cube root the 64y to the third, that gives you 4y. Same sign, cube root the 125, it's 5. And now my trinomial, square the 4y, so 16y squared, opposite sign, multiply 4y and 5, 20y, and lastly, square the 5, so 25. So for the last one, these are still two perfect cubes. It's the difference. So my u value here for this first term, I'm taking x plus 2, x plus 2 raised to the third power. Remember, when you cube root something that's raised to a third power, it cancels it. So my u value here is x plus 2. And then my v value is just the cube root of y to the third, which just gives me y. So now I'll plug it into the pattern. So my pattern, I take my u value, x plus 2, same sign, so subtraction, and then the v, which is the y. Now, the next part is tricky. So remember, this first term here is x plus 2, actually I'll just write it in here, is that u value squared. We're going to have to FOIL this. We're going to put the same sign, opposite sign, and now I have to multiply. So this was, remember, this is u squared, u times v, and v squared. And then here was u minus v, or u plus v, or no, minus. All right, so now u times v, I have to distribute here. So let me just write it first. So it's going to be y times x plus 2. And then I also have the v squared, which is just y squared. Let me do it in blue. Y squared. All right, so now I need to FOIL this. So really what I'm doing is x plus 2 here. So this gives me x squared plus 2x plus 2x plus 4. Once I combine these middles, x squared plus 4x plus 4, I'm going to distribute this y. This gives me xy, 2y, and then I also still have the y squared. And I also had this original term, the x plus 2 minus y. Nothing to combine, believe it or not, in this crazy polynomial. So you just leave it just like that. There are no like terms in that polynomial, no like terms in the first trinomial, so that is your final answer. All right, so when you factor by grouping, you're usually going to have 4 terms. Now, we're also going to use this technique to factor the harder trinomials, where we'll turn those trinomials into a 4-term polynomial. But for right now, in the homework and in the notes, you're going to be given 4 terms. You're going to make pairs out of the 4 terms. Then you're going to factor out the GCF until the parentheses match. Then you'll factor out the parentheses and group together any remaining terms. Now, when you group, the order doesn't matter. So honestly, however it's given to you, if you're able to factor by grouping, you don't really have to rearrange anything. So I'm going to go ahead. I rewrote my original problem. I am going to group the first 2 terms together and make a red group, and then the second 2 terms and make a blue group. Now what I'm doing is looking for the GCF of each one of my groups. So out of my red group, my GCF is x squared. So I'm going to go ahead and write the GCF down, and in the parentheses goes the division after I've divided x to the third by x squared and x squared by x squared. Next, I move to the blue group. My greatest common factor of the blue group is just 2. So now I will put positive 2 here, and then the answer to the division. Now, whenever you factor by grouping, what remains in these parentheses must match. If it doesn't, you've either pulled out the wrong GCF or it can't be factored by grouping. Now that we've done that, we're going to take out the parentheses. Once you have the same, you write that down once, and then you take the remaining terms, the two GCFs, you divide it by, and it creates your second binomial. Now, the order here does not matter. If you would have preferred to pull the two GCFs out first, and then the parentheses that are in common, and write that second, the order doesn't matter. Remember, whenever you're going to factor this by grouping, you can FOIL this or multiply it back, and if it goes back to the original, then you've done it correctly. If it doesn't, you've made a mistake somewhere. So first one, again, I'm going to group it how it's given to me. I'm going to make a red group and a blue group. I'm going to look for my greatest common factor of my red group, and that's actually going to be 2x squared. I'm going to write down the GCF. I'm going to write down what I get when I divide. And now I move to the blue group. My greatest common factor here, notice the 9 does not have a variable, so my GCF is just positive 3. Now again, once you divide by that GCF, what remained in the parentheses must match. If your signs are off, you either pulled out the wrong GCF or it can't be factored. So now that I've found that the parentheses are the same, write it down once, and then take the two remaining terms, the GCF, and that becomes your second binomial. And you're done. And again, if you would have preferred to write the 2x squared plus 3 first, and then the 4x cubed minus 3 second, it doesn't matter. Now let's try a next one. So again, red group, blue group. My greatest common factor of the red group is going to be x squared. Write down the GCF, divide it, and now I need to look for a GCF of blue. Now, watch what's going to happen. At first glance, you might say, oh, I'm going to pull out a positive 5. But if I do that, what remains does not match. So in this case, what I really need to do is now go back and pull out a negative 5 GCF, and then my parentheses will match. Now, some Algebra 1 teachers teach you to pull out the positive 5, then go back and pull out a negative 1. You can do that as well. So then now, negative 5, I'm going to divide it. Negative 5x divided by negative 5 is now positive x. Negative 5 divided by negative 5 is positive 1. I now have my match that I need in the parentheses. So write that down. And again, take the two GCFs. Now, also keep in mind that if after you group something, like say the GCFs, if that were the difference of two squares, let's say that 5 was a 4, then you'd keep going. So there's going to be some where it's going to say factor completely, and you got to keep on going and going and going, just like on the test yesterday. All right, let's try another example. All right, next one. Again, I'm going to make a red group and a blue group. So from my red group, it's going to be x cubed again. Divide it, x plus 5. GCF of blue. Now, again, as soon as I see that these are both negative, that's going to be a clue that I'm going to be pulling out a negative GCF. Again, if you try the positive 5 and you see that you don't have a match, then go back and redo it. So this is a negative 5. Negative 5x divided by negative 5 is positive x. Negative 25 divided by negative 5, positive 5. Again, group the GCFs and write what's in the parentheses. Again, the order of the binomials doesn't matter. And then the last example, red group, blue group. GCF of red is going to be x squared. Divide it. You're left with 3x plus 1. GCF of blue, and again, if I pull out a 5, it's not going to match. So I'll pull out a -5, and then it matches. So now that I have the same, write that down once, and again, group the GCF. And again, if anything in these binomials that you create could still be factored, you keep going.